Chapter 15, Objective 2 says, know how to calculate the change in heat or enthalpy. And what I've given you is really a two-part or calorimeter problem. Sometimes you're just looking at your sample and there's only one step to it, but oftentimes when we're looking at enthalpy changes, we use a calorimeter. And the whole idea of a calorimeter is based off the idea that the heat lost by any object, delta H for the object you're interested in, is going to be equal to the heat gained by the water. So if this object loses heat, this one gains it. If this object gains heat, this one loses it. But you surround the object by water and let the heat transfer take place. So you have a 275 gram piece of hot metal. So the metal has a mass of 250 grams. Drop from boiling water into 100 milliliters of room temp water. 275, thank you. So if it's 100 milliliters of water, since it's water, we can assume its mass is 100 grams because its density is 1 gram per milliliter. Temperature of the water changes from 28 to 54.5. So that's going to be what, like 26.5 is my delta T. Delta T for the metal is, how would I figure that out? This is where a lot of people screw up. I'm going to have to subtract 2 temps. What's my starting temp for the metal? It's 100 because it was in boiling water. What's my final temp for the metal? 54.5. That's why the water quit heating up. The water heats up until the metal quits cooling down. So the metal and the water should have the same final temp. So this is going to be, is it like 45.5? And it says how much heat was gained by the water. Well, delta H for anything, we use MCAT, mass times specific heat times change in temp. So my mass for the water is 100 grams. My specific heat for water is 4.18. You just use the 2 decimals is fine. And then my temperature change was 26.5. So for the water, delta H is 11,077. What's the unit for this? When you calculate MCAT, what unit's your heat in? It's in joules. It's not kilojoules. It's just joules. So then if I want to know what's the specific heat of the metal, well, I'm going to assume this also is delta H for the metal, so I can plug in 11,077 for delta H for the metal. I can plug in the 275 for the mass of the metal, and I can plug in 45.5 for the temperature change of the metal, and then I can solve for C. So if I do that, I divide by the 275, divide by the 45.5. My C value is 0.885, and that's joules per gram per Celsius degree. If I wanted to know how many kilojoules per gram the heat loss was for the metal, I could change 11.077 to kilojoules and divide by the 275 grams. There's various things you can do from off of these problems. Okay? Finding the heat loss per gram. And again, another common mistake. If you want to know the heat loss per gram, we'll squeeze it in here. Heat loss in kilojoules per gram. Change that to kilojoules. And divide by how many grams was in the sample. That's kilojoules per gram. There's not a formula for it because it's so obvious. Unless you're a freshman chem student, that's not so obvious, but this is 0.043 kilojoules per gram. We usually change it to kilojoules per gram so we can compare samples, equal amounts of samples.